Stationary points, differentiation. Example 2. A, the curve y equals 1 over x plus 27x cubed has its stationary points at x equals plus or minus a. Find the value of a. B, sketch the graph. We know at the stationary point, we know that the y, the x, equal to 0. And we're told to find the value of x at the stationary point. First of all, before we start on this, let's just talk about this. At the stationary point, we know the line is horizontal. That means the gradient is 0. So the y, the x, equal to 0. But for now, we're just going to find the value of x when this happens. And the stationary point is also called the turning point, or it might be a point of inflection. But in this case, we should see what we're going to do next. But let's find the value of x at the y dx equals to 0, which is, we go to make sure that the function y is in that format. 1 over x is not in the same format as x to the power of n, so we have to convert 1 over n. In indices, 1 over a to the power of n is equal to a to the power minus n. So in this case, a is x, n is 1 here, and then y equals x to the power minus 1 plus 27x cubed. Now we can apply the y dx. There are two terms here, so we have to differentiate this term by term. The y, the x, equals minus 1 x to the power minus 2. The y dx equals minus 1 x to the power minus 2. N is minus 1, so minus 1 times 1 is minus 1. X minus 1 is minus 2, because it's minus 1 is minus 2. Plus 3 times 27 is 81. X to the power 2, because 3 minus 1 is 2. At this point, at the stationary point, so at the stationary point, we know that 81x squared minus 1 over x squared. So I'll just rewrite. I change that format to that, equal to 0. So that's the gradient and equal to 0. If I multiply both sides by x squared, we get 81 x to the power 4 minus 1 equal to 0. I multiply both sides by x squared to get rid of the denominator x squared here. So x squared divided by x squared is 1. And that's x to the power 4. X squared times x squared is x to the power 4. Add 1 to both sides or move 1 to the right. 81 x to the power 4 equals 1. Divide both sides by 81. So x to the power 4 equals 1 over 81. That x to the power 4 equals 1 over 81. We could rewrite this as x squared all to the power 2 equals 1 over 9 all squared, because 1 squared is 1, 9 squared is 81. So these two can cancel each other because they're powers and they're the same, which implies that x squared equals 1 over 9. But x squared also can be equal to 1 over 3 all squared. But we need plus or minus, right? Because whenever we're dealing with squares, we always do plus or minus. Minus 3 times minus 3 is 9. Plus 3 times plus 3 is 9. You can see you need a plus or minus. Therefore, x, because the square again cancel out, so x equals plus or minus 1 over 3, which means a equals 1 over 3. Now we've found the value of x, where the dy dx is 0, the stationary point or the turning point. Therefore, when x equals 1 over 3, y is also 4. Because if you put 1 over 3 back into that function y, you get 4. And when x equals minus 1 over 3, y equals minus 4. So these two coordinates, one of them is maximum and one of them is minimum. They're both turning points, but one of them is maximum, one of them is minimum. We need to determine which is maximum, which is minimum, with a straight line, as we said, and that's the dy dx equal to 0. So we said dy dx equal to 0. If the second derivative is positive, like that, so that's not 0, that's positive, right? This is the first derivative, and we equate it to 0. Okay, if we differentiate again, and if that's positive, let's just call that the 2y dx squared. And if that's positive, that means greater than 0. Then you can see this is minimum. You see that? That's a minimum, like a bucket. So that will be a minimum, right? So that's minimum. Or if we differentiate again, and it wasn't positive, but it came out negative like that, which means the 2y dx squared is less than 0. What's going on? So I'm going from 0 to negative gradient, so that must be a maximum. So that's maximum. So that's what we're trying to determine with these 2 points. One of these points here, that's a point, that's a coordinate. One of these coordinates is a minimum or maximum, and the other is minimum or maximum. So that's what we're trying to determine. We then need to find the 2y dx squared. So the 2y dx squared, we know the y dx. The 2y dx will be, well, minus 2 times minus 1 is 2. And then minus 2 minus 1, because I'm applying that again twice. So that will be x to the power minus 3 plus 2 times 81 is 162. X, 2 minus 1 is 1. And that will be 2 over x to the power 3. So converting back, plus 162x. And that's the 2y dx squared. So now we need to plug in the x value here into there to find the value, the 2y dx squared. And if that's positive, then we know it's a minimum point. If it's negative, then we know it's a maximum point. The 2y dx squared, when x equals 1/3, we get 2 over 1 over 3 to the power 3 plus 162 times 1/3. We know what that would be. That would be 2 over 1 over 27, because 3 cubed is 27. 1 cubed is 1 plus 162 over 3. And, well, that's just 2 times 27, that one, because 1 over 1 over 27 is 27. That's 2 times 27. So altogether, this turned out to be 108. So that's positive. It's greater than 0. It's minimum. So that's the minimum. Now we need to do the same for x equals minus 1/3. So the 2y, the x squared equals when x equals minus 1/3. So that will be equal to, well, it's actually the same thing, except This is negative, so that will be minus 27 times 2. And this will be negative 2, so that will make this minus 108. Be a maximum because it's negative here. So you go from 0 to negative, so that's a maximum, so that's maximum. We can sketch now for part B what the curves looks like. We know the function is y equals 1 over x plus 27x cubed. Well, first of all, this y, 1 over x, has a vertical asymptote because x cannot be 0. Because if x equal to 0 here, then 1 over 0 is undefined. So when x equal to 0, that's the vertical asymptote. Now, sketching this curve, the line of asymptote is when x equals to 0. So this is x equal to 0 here. That's the y-axis. So that will be the line of asymptote. That means the curve will approach it but never crosses it. This is x equals 1/3, and this is x equals minus 1/3. So it's a mirror image. And at that point, x equals 1/3, y is 4. So that will be 4. X equals minus 1/3, y is minus 4. And this is a turning point. Now, x equals minus 1/3 is a maximum, which means the curve will approach and comes back, but never touches the line of asymptote. And at x equals 1/3, it's a minimum. So that means the curve will approach and it goes that way. You could, if you're not sure, you could plot values greater than plus, and you see that the curve is on the positive side here. When x is 1, when x is 2, you will still get a value that goes up. So that tells you where the curve is. So you could try smaller values here. You can try smaller values here. You can see the curve will be greater than 4 here and also greater than 4 there. So then but you know that the curve will never crosses that line, the x equals to 0. So this line is x equal to 0. That's the vertical asymptote. It will never cross it. Likewise, you can plot some value for between 0 and minus 1/3, and even beyond minus 1/3, say minus 1, minus 2, and you get some values here. You can just plot them in, and that's what the curve will look like.